Okay, so hi guys, good morning everyone. So thanks for joining us on this Saturday for TechMe 360 event. So I appreciate your interest. So today, we have an event called Global AI Bootcamp. So I'll give a small introduction about what is this event and who conducts it, etc. So basically, there's a community called Global AI Community. So they organize boot camps like AI boot camps across various cities, very in the whole country. Like there are various locations, as you can see. There are a number of locations they are organizing across various countries. So from India, from Coimbatore, we have Techmeet 360, and we are doing a 2 hour event today, like 10 a.m. to 12 p.m. Where we focus on where we will focus on exploring Azure Cognitive Services. So it's first session will be a kind of a very basic session, like where we'll explore some basic Azure Cognitive Services, and second session will be on like machine learning. Like this session will start from basics. We'll see what is Azure ML and how you can explore it, how you can configure, and how you can train your model, etc. And then the third one is like how you can build a chatbot. Like there are various chatbots available in various kinds of applications like Swiggy, Zomato, etc. So we'll see like how you can create a chatbot, something like that. And the final session will be like how to build a canvas application with Azure Cognitive Service. So this is a kind of, we'll start from basic and we'll cover some how you can do it. We'll have a demo of how you can do it. So we have 4 sessions. Like if you have any questions at any point of time, you can raise it in the comment section. We are happy to take it. So the first session is by Shiva Ramakrishnan. Like he'll be explaining us like about what is Azure Cognitive Services, etc. So over to you, Shivaram.
Yeah, thank you, Sadash. I'm sharing my screen. Hope you are able to see my screen.
Yes, Shivaram, you can go ahead.
Yeah, thank you. Yeah, hi all. Good morning. So hope you are all doing well and safe in this situation. I would like to thank this opportunity for COVID.co and Technique 360 community. So just introducing myself, like I'm Sivaram Krishnan, working as a senior technical product support engineer at COVID.co for the past 7 years. So I have years of experience in Azure and then completed a few certifications with regards to Azure from Microsoft. That's in my build. So the today agenda is like we're going to see like what is cognitive services and types of cognitive, and then few demos as well. So yeah, so the Wikipedia definition. So the mental action or process of acquiring knowledge and understanding through experience and senses. That's called cognition. So before getting into cognitive services, let's see a small video clip that gives you an idea like how the cognitive services were implemented in a real time and how it is changes lifestyle. We will see a few videos and demos as well throughout this session. Yeah, so let's see a video.
I'm Sakib Sheikh. I lost my sight when I was 7, and shortly after that, I went to a school for the blind. And that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces. 40-year-old man with a beard looking surprised. 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo,
Move camera to the bottom right and away from the document.
and then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do. But artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far off dream and building it one step at a time. I think this is just the beginning.
Yeah, so in this video, like if you have taken a closer look, there were a lot of artificial intelligence were used, right from text search and then image search and then the sentimental analysis, how the person is reacting and then their age. So many things. So next slide. So I would like to show you out. Uh, sorry. Yeah, so let's see what is the cognitive services. So Azure Cognitive Services are nothing but APIs and standard development kits, and the services available to help developers build intelligent application without having direct AI or data science skills or knowledge. Like basically, like you don't need you don't need to be a perfect developer or you don't need to code mostly. So Azure Cognitive Services enable developers to easily add cognitive features into their application. The goal of the Azure Cognitive Services is to help the developers create application that can see, hear, and speak, understand, even being to reason. The categories of services with the Azure Cognitive Services can be like categories into five major pillars, like vision, speech, language, and then decision. And last but not least, like web search. But now they have implemented. It is not an option now. We want the machine to draw out those sentiments and tell us with what degree of confidence those semantic interpretations are correct, and if we can get some structured data values or entities and in and out, then even better. So it will automatically identify more than 1,000 objects and then 25 languages so far, like streaming process across multiple scenarios such as a robotic process, automation, and digital asset management, rich data extraction for each. So the next slide will be again an video, like the before video, you have seen how a common man is using you know uh, in a day-to-day life. So this is implementation in a well-known organization, and let's see the use case as well.
We come to work every day to pilot, test, and launch new technology solutions. Real-time ID check is the latest technology example where we at Uber are constantly developing and testing new solutions to predict, prevent, and reduce security risks in ways that weren't possible before. It's through this partnership with Microsoft that we've been able to develop this technology quickly and ensure that every rider and every driver has an excellent experience. Real-time ID check is a prompt that appears in the driver's app, asking them to take a self-photo. We can do a check in real time to make sure that that identity of the person who took the picture matches the account holder who's been approved to drive. Doing that serves a couple of purposes. Drivers know that their identities and their accounts are being protected. and riders know that the driver who they're with has been screened.
Jen? Yeah.
Real-time ID is a smart technology. What that means is it factors in and addresses the edge cases. The situation where the driver is wearing glasses or a hat and they weren't in the identification that we have on file. The beautiful thing is it can recognize these changes and ask the driver to remove their sunglasses or retake the photo. The partnership with Microsoft Cognitive Services allowed us to go from idea to execution to implementation across the country in a matter of months. Already, we've been able to make thousands of rides safer, and very soon we're going to be making millions of rides safer through this technology.
Yeah. So I would like to give a case study, like if you are developing this particular app, like with the face recognition and then the tracking everything, like it may take like months and months to build this particular software. But using this cognitive services, they are completed within 3 weeks of time, like comparing photos with various processes and focusing, and even with dull lights, and then with critical for uncontrolled conditions. So these things were handled by the cognitive services, and these two, like it will match within like milliseconds. So now, like let's get into the types of cognitive services. So the cognitive services were categorized into four major sessions: decision making, and then language, and then speech, and then vision, and web search. So web search is now discontinued, and because like this has been implemented in the Edge browser. So the services like there were 27 services were available. So if we discontinued, including the web search. So let's have a look at the decision making. So yeah, so Hans user feedback in real time to present a personalized multimedia experience, including ranked shopping, placements, recommending new articles, and relevant video content. Like retail, media, e-commerce, and many other industries have long pursued the holy grail of personalizing the experience. Unfortunately, giving customers more of what they want often requires string together various like CRM and DMP, like name, uh, testing days and night. Reinforcements learning is this set of techniques that allows AI to achieve a goal by learning from what's happening in the real world. Only the Azure delivers this powerful reinforcement learning burst community through a simple to use API with a personalizer. So like like this personalizer, like sorry, decision making is divided into three, like personalizer, content moderator, and anomaly detector is in preview. Like I'll let you know later. So let's see like the personalizer. So within if you are using Microsoft Teams, like within Microsoft Teams, there are using personalizer to enhance the user experience. And if you saw Xbox, like 40 percentage lift in the engagement by using personalizer to display the content to users that will mostly like based on the interest of the individuals. The user-friendly interface to monitor and adjust the learning loop according to the parameters and then the KPIs, and automatic model optimization based on reinforcement learning and allowing AI to achieve the goals like what we set. And let's see the content. So the content, like it has been divided into like four major sections, like image moderation and text moderation, video and human view tool. So the detection of potential offensive and then unwanted images, filtering or possible and undesirable text modern of adult and then racially content in videos. So the image moderation enhance your ability to detect potentially offensive or unwanted images through the machine learning based classifiers. custom list and then optical characters recognition. That's where available. And text moderation used content filtering to detect potential profanity in more than 100 languages, like flags, text that may be deemed inappropriate depending on content. Um, and video moderate enable machine assisted detection of possible adult and then racy content in videos. This will be finding those unwanted images and and removing those images in with to public. And the human view tool is nothing but the best content moderation results comes from the human and machine working together. So use these review tools when critication conference can be improved or tempered with the real world content. So let's see a demo. Yeah, sorry. Yeah. So if you could see it, this personalized demo. um Yeah. So if you see weekend, the time and then the things it will show in the context in JSON as well, the rewards and then the personalizer how you want to show everything will be captured here. Okay, I move the slide. Okay. This will show like the personalizer chooses content and how to the application teach the services to improve suggestions based on the rewards and the things. Moving to the languages due to the time being. Okay, so here in the language, the language APIs for use for spell check, natural language understanding, linguistic analysis, and then sentimental analysis, and then topic detection and more. So entirely recognition identifies the key terms and phrases, understand sentiments, and build conversation interfaces into applications, and then are not trying evaluate and deploy customable modes using the cognitive services for language without machine learning expertise. So sentimental analysis detect sentiments, key phrases, and then named entities. Basically, this will analyze, and provide a score based on the text what we provided. And question and answering is nothing but create a conversation questions and answer layer out your existing data with the question answering. And Azure Cognitive Services for language feature, and then the translator, it will translate text instantly or in a batches across more than 100 languages, powered by the latest innovation in machine translations. And uh, yeah, conversation language is nothing but understanding build application with conversation language, cognitive services for language feature that understand natural languages to interpret user goals and extract keys information from the conversational phrases. So I'll show the detail. I plan to show it out language understanding, but I'm skipping for this. We will see the sentimental analysis in detail at the later part. So the next will be speech. In speech, it has been divided into 4 sessions. The speech API for converting text to speech, and then speech to text as well, performing voice verification and identifications as well. The speech to text convert spoken audio to text for more natural interactions, to swiftly convert audio into text from various variety of sources. Also, like custom models to overcome common speech recognition barriers such as unique vocabulary, speaking styles, or background noise. These will be identified. The actually the Bing speech brings speech to text to application, allowing you to use voice as more natural input. The audio can be come from your microphone, files, or any other audio sources. Results can be returned in real time as the audio is set to services. And recognition can also be combined with other services. For example, you can get more intent speakers phrase directly from the APIs after some training. So, and of course, like there is also text to speech, so your application can respond in kind of a number of languages and voices. And again, text to speech, like it will convert the lifelike speech to more natural interfaces, like used to text to speech, part of speech services to build apps. And sorry, and yeah, so speech translation is like easily integrate a real time speech translation to your app. If you are creating a game or a voice interface to a specific tool, you will want to be sure that domain specific words and then the phrases don't trip using the recognition system. And speaker recognition, like again speech regulation, like it will be a point to handle your speak scenario, like extend to reach your application, and building customized speech translation systems. The last but not least, like speak recognition, this will identify individual speakers or use speech as means of verification with the speaker recognition. Yeah, so I'll show you a quick demo. So, the speaker identification, speaker verification, and security things will be available. Um, so, these are the some SDKs that's available, under the languages. Okay. So the next thing will be Vision. So Vision that will Vision API for extracting information from images, recognizing emotions in images and videos, detecting and identifying faces in images, and detecting motion in videos, and more speech APIs for converting text to speech and text to speech and sorry text to speech as speech to text as well. So computer version will generate descriptions and search metadata for images, and detect face and recognize celebrities in image, and read text in images, like check images for adult content, generate smart image thumbnails, and then more. Vision, so custom vision is like it's an AI service, an end-to-end platform for applying computer vision to specific scenario. And face API, like face detector that precise faces and attributes in an image, person identification that matches an individual in your private repository from up to 1 million people can be used here. And then so
Every company that has a large video library faces the same problem. Tagging videos manually is expensive and often leads to errors. Introducing Video Indexer. Using advanced AI technologies, this service can automatically extract metadata from any video, spoken words, printed text, faces, emotions, and more, helping clients easily search, review, curate, and publish much deeper insights from their content. Imagine being able to easily search specific people, find everything they said on a particular topic, even get a transcript translated to a different language, search street signs or words on screen. This advanced way of indexing video can be used to help customers build intelligent apps, such as deep search, personalized recommendations, automating video, targeted video advertising. The possibilities go on and on. Video Indexer can efficiently help news agencies and sports broadcasters monetize their content, help retailers, manufacturers, and smart city tech providers easily improve their business insights at any scale you need. And speaking of flexible, you can use it without writing a single line of code, or embed it into your application using APIs. Want to see it in action? Sign up for a free trial with just an email address. Upload a few videos and see how this exciting new service can help get more out of your content now, only with Video Indexer.
Yeah. So, in the like, I would like to show a ink recognizer demo. Like, let me show the ink recognizer how it works. So, I'm going to, insert a text box. Okay, I'm inserting a text box. Like, I'm going to draw something. Okay, I'm going to draw something. Let me put. Okay, so I'm going to select this per certain region. Okay, I've selected this. Next, like, I'm going to link into a text. Like, this has been, now it has been converted into a text. Like, so this will be helpful. Like, when you take a note, definitely this will be helpful. Okay. So the search has been discontinued, but I would like to just show you out the search APIs for offering suggestions and performing, sophisticated searches. This has been implemented, as I said before. Like, this has been already implemented in the Bing search engine, which has been owned by Microsoft. So you can do a quick search. So and you can easily notice all these features will be available there. So the next search will be the web search. Uh, okay, I'm skipping this. Okay, so the next will be a Language Studio. A Language Studio is a set of UI-based tools that lets you explore, build, and interactive features from Azure Cognitive Services for language into application. A Language Studio provides with you a platform to try several service features and see like what they return in a visual manner. So this has been like into 4 sessions. Interactive information use natural language understanding to extend information from unstructured text. Like, use tools in order to do things like identify key phrases or personally identify informations. So classified text is nothing but like using natural language understanding to detect the language or classify the sentiment of any piece of text that you have, and answer questions. So I mean to say that, like, this is a part of sentimental analysis. Okay, and the answering questions provides you to questions being asked your unstructured text using our pre-built capabilities, or choose the customize of your domain specific answers and pairs. And understanding conversational language, create your own conversational language understanding models to classify conversational and extract detailed information from the fulfilled scenarios. So I'll just show you talking a quick demo. So for this, like I'm going to use out uh, the Microsoft Azure Cognitive page. So when you enter this, this will ask you to select the Active Directory. So I'm selecting the same Active Directory which I have before, and then I'm selecting the subscription. And we have to select the language resources, but unfortunately, like we don't have the language resource that we created or mapped within here, since I have deleted that language resource. um, so I just like to show you out like how the sentimental uh, okay. Okay, so since I have deleted few of the things has been disabled now. uh, okay, I'll show you like custom question and answering. Okay, okay. It's asking for. Mm, okay, I'm sorry that like I have since I have deleted this has been most of the things were not available. Um, Let me try. Okay, now this has been available. So I'll just try to select the sentiment and analysis. So what I'm going to do is like I'm going to select a detect auto language. So this will be detected by its own. So I'll just select the sample text. So it's saying that I had the best day of my life. I'm going to run this. So this will provide the results, like the how positive it is and how confidence those those things has been shown here, and then the sentimental analysis how positive it is. I'm going to try out the next thing. So there you can see like some of the places were being captured here, and then the place. So I'm just going to run this, and you can see out like how the document sentiment has been, and then how positive and then the negative, and then you can see some of the um, things has been captured like the sentimental analysis, and then you can see the places as well that we will see in another one. And as well as like this can be also provided in a JSON format as well. So I'm going back to Language Studio, and then okay, let's try question and answers. So here, like we want to provide uh, question. I mean, we will provide a paragraph, and within the paragraph, if we raise any questions, it will answer. For now, like I'll search about Gandhi. Okay, let's see. Let's take it out from the Wikipedia. What we give. Okay, I'm pasting out. Okay, so I'm going to raise a question. Who is the father of nation? Let's see what it replies. Okay, so the long answer is Gandhi, and some of the text, and then the short answer is Gandhi, and then it will share like how confident it is, and then the language. So this is how the language studio will work, and let me try to quickly complete it. So these are the like once you get into the once after creating a resource group. So resource group is nothing but a logical container. Once after entering into resource group, you have to select the AI and machine learning. So these are the features that it will provide for you. And also, like, you can directly just go to the search panel and type what are the um, like cognitive services, and it will provide the cognitive services list. And the next will be the pricing. The pricing is the advantage, the pricing is free, uh, 5k 5,000 transactions per day under free subscription. And then there is also a paid subscription were available, like pay use as you go. And then, like, the main advantage of this is, like, it is nothing but, like, this is mostly this is zero code. As I mentioned, the Uber, like, this is a zero code. You have to just implement those cognitive services into your code. That's it. So if you have any questions, like, you can ask in the chat box. I'm happy to reply in the chat box. And as well as, like, you can contact me in the page, like Twitter, and then LinkedIn and Facebook. Yeah. Thank you all, and have a
Yeah.
nice day.
Yeah,
Yeah. Thank you
thanks,
all.
thanks, Shivaram. So thanks for the session and thanks for the demo. So guys, if you have any doubts, you can reach out to him in the social handles like Twitter, LinkedIn, or Facebook. So thanks, Shivaram. Thanks for the session.
Yeah. Thank you all. Bye.
Okay, so the next session is by Elil. Like she'll be talking about machine learning. So over to you, Elil.
Thanks, Suhas.
Yeah.
Yeah, hope you all can hear me good and see my screen.
Yes, Elil.
Yes. So wonderful morning to all of you here joining us on Saturday to explore the AI part of the world. Let me quick check. Hear me good and see my screen. Yes, Suhas.
Can you reshare your? Yes, I'm able to see the PPT. Yeah.
Okay, yeah, that's awesome. Yeah. Wonderful morning, everyone. Again, I am Irilaracy. I am the lead product consultant of Serverless 360 at Covai.co. So, Serverless 360 is a tool that has been built for Azure experience improvement. And today I'm going to talk about one of my latest passions in the Azure space, machine learning, and what Azure has got to offer as machine learning services. So let us together explore what machine learning is and how Azure can help you build smart, intelligent applications using machine learning services. So we should first understand the necessity of us discussing about this topic today. Let's observe the digital transformation trends, how it has been. So especially in the last couple of years, the business has changed drastically. Not only the business, the way we build the business applications has gone through an immense transformation. And what has caused these transformations? What are the areas of businesses that is going through this possible digital transformation? We all are working from remote. There is a drastic change in the business strategy for whom we are building. What are we building has gone through a major transformation. The way we interact with our customers, the workforce, business operations, and business models, everything is going through a drastic digital transformation. And to compete with this, to stay attuned with the changes that demand the changes in the digital technology, we need to keep up and upgrade our technology front as well. And that is where smart technology gets emerging, and a few of the technology services that are drastically developing are cloud computing, artificial intelligence and machine learning, blockchain, biometrics, customer experiences, security and privacy, conversational UIs, and IoTs. So these are some emerging technologies that are drastically evolving. My expertise being in the cloud computing sector, I wanted to explore much into another emerging upcoming technology, and that is where my interest into machine learning came in. And I'm happy to share my learnings in the past few years in the machine learning area with the community. Going ahead, let us start with the basics. I always believe you should have a strong foundation to take things better and have a better understanding, or to evolve or innovate in the space. So here let us try to understand three basic models of machine learning. So first of all, what is machine learning? We are going to educate the machines to handle the data better way, in a much faster way than human beings. So they are not going to rule us, at least not now, as of now. So you can train your machines to do or assimilate the data that we have generated over a last decade of time. So as you observe, the digital usage has increased drastically, which in turn has it led to an accumulation of more volume of data, which is practically not possible for a human to process. So that is where we need to delegate this activity to a machine which is equipped by a human with appropriate algorithms and programs to possible to process the data and give us useful insights. So that is where machine learning's nutshell is. So let us try to understand what are the three basic models that machine learning has got into, right? So supervised model. So here I have, let us understand the first scenario, wherein we tell the system that if an object has six sides which are equal, then you call that as an cube. So we tell the machine and give the machine and labeled data. We tell that this object is expected to have six sides, and each side of the object will be a square, which means all the sides would be equal. Yeah. So this is the understanding that we give to the machine to judge any incoming object. So when I pass on a new object to the machine, it is going to recognize it as a cube if it has six sides and if it has all the six sides to be n square. So that is in supervised learning. So here I am educating the machine with a labeled data with which it can recognize any future data that is fed as an input to the machine. But real time demands would be much more, isn't it? So I need my mission also to be unsupervised learning capable. So here I'm going to give it a bunch of data, and I allow it to build a relationship. So I allow the machine to categorize them into different possible categories. So it could be based on the shape, size, length. I allow the machine to decide. So in this case, the machine is going to be trained again and again to understand the data and come up with relationships that are possible. So imagine I have given it a bunch of objects. Some of them are cubes, some of them are cuboids, some of them are cylinders, and I allow the machine to cluster them or categorize them into various groups. And the machine comes back to me saying that these looks like these many groups. Yes. So there is another advanced machine learning model that fits into a number of our real-time scenarios, whereas reinforcement learning. Here, I allow the machine to experience how does it work. Imagine I play EXO with a friend of mine, and the first time I do not know how to play. and the next time I learn what actions of mine is going to lead me towards the victory, and I allow the machine to perform the same. I educate the machine on the rules of the game, and I allow the machine to play. Let it take the opportunity to play, fail, reinforce. That is, whenever it fails, it gets a feedback and changes it. And I give it a complete continuous feedback, that is a reinforcement, to make sure that it moves towards the ideal case. So these are certain three basic models of machine learning, and this is how machines are trained to become intelligent and help us with complex in real-time situations, so that we can sit back and relax. So, where have we observed machine learning in our day-to-day life? So, at this point, we should also take a pause and then imagine where have we utilized or where have we observed machine learning. In fact, everywhere, right? You have seen self-driven cars wherein machines are helping us drive, and more than 50 types of eye diseases can now be automatically recognized by machines. And where not, say I log into my Netflix ID, I get recommendations. How do you think this is happening? The underlying machine is getting intelligent. It is trying to understand what are my preferences and what is my preferred language, what is my preferred genre. All these are being understood by the underlying machine, and that's how it gives me the recommendations. I log into Facebook, I get recommendations as a form of ads. How does that all come in? Through the understanding of data collected through my various online usage. Say I would have made a shopping in Amazon, I would have watched a movie in Netflix. All these are put together, and there is an processing of humongous amount of data that is reflecting on my Facebook page in the form of ads. So, how are all these being done? There is an intelligent machine underlying which is taking care of all that. Yes. So we are knowingly or unknowingly using applications that are built using machine learning services, and when we go to the other side of building them, we need to understand what are the technology assistants that I get from the service providers, or how do I actually build these machine learning solutions. That is the space that we are stepping into now. We being on the developing end, we need to understand how does a typical machine learning project life cycle look like. Again, here it completely depends on a specific business. There could be certain changes or certain new phases that get introduced depending on our specific business need. But in generally, this is how a typical machine learning project life cycle would look like. The starting point would be a definition of a task. That is, what is that I would need to achieve through this project? And for the machine to be made intelligent, I need to understand or prepare and data, explore and prepare data. For that would help my machine understand the business that I am dealing with. So let us take an example here to understand things better. Say, as I mentioned, I work for a product called Serverless 360, which is trying to make people's Azure experience better. It's a support platform built to support Azure applications in production. So we every product for that matter will have an customer base, and we aim at increasing the customer base, isn't it? So we decided to make a very cautious step or very informed decision in this customer acquisition. So what we did is we went back and looked at the information of customers we have acquired till now, like from the day the product has been introduced to the market, from the first customer till today. We try to analyze the customer nature across various parameters. So, what is the organization they are from? What is their business domain? Are they from banking sector, healthcare, or or entertainment industry, communication industry, or energy and gas. So we try to segregate their which business domain are they from, and who is the target user of the product, who in the organization, what is the role of the person who is using the product, and what was their Azure footprint when they started using it, what was the key selling feature from the product that made them do the buying decision. So these are certain parameters that we try to arrive at for each of the customers we had till date. So this is simply an exploration and preparation of data. So what our aim here is to supply the existing data to the system and train and validate it to find out our prospective customers. That is from the whole lot of business people which we can source from various places like LinkedIn or lead feeder. We wanted to scrutinize and then identify who all would be our potential prospects so that we can reach out to them, show the product, and convince them and get the deal, win the deal. That is the idea here. For which the first step would be to prepare or explore and prepare the data. So one point that I need to emphasize here very strong is this data is what is going to define the efficiency of your complete project. Only when you pass on the right information, you will get the right output. Garbage in, garbage out. So you need to make sure that the data that you give is accurate and correct to the best of your knowledge, and more the sample data that you give in, better accuracy is what you can attain. So in case, for example, if I am trying to do an stock market prediction, which means I need to give the information about the last few years of stock market data, that is details to the system, so that I get a more accurate result. If I try to give last 3 months information, you cannot expect the output also to be very accurate. So this data is a core of building this ML project. Yeah. So once you explore and prepare the data, the next step is to train and validate the model. So here you would have built a model. When I say building a model, it would involve multiple steps wherein you would define an orchestration which contains of multiple steps. This would involve coding to build, like match your logic. Say, let us take the simple um, problem statement of identifying whether the object is cube or not. So here you need to feel the object, evaluate its sides, take the measurement of the sides, and then make sure that it is n square. So this train and validate is where you build your model and train it with this data, validate whether it is correct, and then in case if there is any changes, this is the phase where you define the logic or define the implementation of your machine learning model. Once training and validation is done, you need to deploy the model. And here is where this ML machine learning ops comes into picture, just like your DevOps, wherein you develop and um, deploy and make it available to your customer. Machine learning ops is specific to machine learning projects, wherein you monitor and you manage the complete life cycle, taking advantage of the right tool set that can help you with build, develop, and deploy. So this is how an life cycle looks like, and it keeps going on. You feed the you update the data, you train the model, deploy it again, and then monitor it for any changes. You modify the data, and then this keeps going on until your project achieves the desired output. So what does Azure has got to offer or facilitate me building these machine learning projects? So as we discussed, we need an computational service that will help me run my machine learning model, isn't it? So this needs to be executed. So Azure offers scalable on-demand compute services, and the data is a core of a machine learning project. You have data services like in storage account blob or data factory pipelines, data lake storage. So you have multiple options even in the data storage services to choose from. You can orchestrate your machine learning workflow in Machine Learning Studio, and you can model and register and manage your solution right from the Machine Learning Studio with the choice of the language of your preference. It has got integration to wide range of open source services as well and libraries as well. You can monitor the metrics of your services that you have created and have a continuous eye on how things are going on. It is also possible to deploy. That is, Azure supports the complete life cycle of your product development. So here, let me take you quickly through what like Azure has got to offer. Azure has support for the complete end-to-end machine learning lifecycle. So we just talked about preparing data. You can use the services to do data labeling. As I mentioned, you have various services in the data factory pipelines and data storage lakes, data storage blobs, which you can take advantage of to do the data labeling, data preparation, and data sets. You can create and access data sets, and you can share them across the services to be utilized. You can build and train your models. So you have got the automated ML services, which I would show you. You can use the advantage of drag and drop designer. Even if you're not an expert in development, you can take advantage of the designer view in the ML studio, wherein you can drag and drop the existing um, components to build your ML solution. You can take advantage of the compute instance. So there is no pre-computational cost. When you execute your machine learning project is where you start paying. You can associate your machine learning workspace to an compute instance which can scale on demand seamlessly. And you can take advantage of the open source libraries and frameworks. So Azure is the only place where we can find integration to PyTorch framework, which is one of the best machine learning frameworks coined by Facebook AI Research Lab. And you can validate and deploy your solution right from Azure Machine Learning Studio itself. It has support to define your pipelines, CI/CDs, that is continuous integration and continuous deployment is feasible when you choose Azure as your machine learning service. And you can also order and have a control on the entire infrastructure right from the Azure portal. So, what is that is required to get started with this? So you need to have an Azure subscription. If you do not have one, you have an option to create one for free. So once you create an Azure subscription, you can get started with a Microsoft Azure Machine Learning Studio. So once you get started with the Machine Learning Studio, it will prompt you to create an machine learning workspace in your Azure subscription, which is also facilitated right from the Machine Learning Studio. When you create your machine learning workspace from the machine learning studio, you can see that getting reflected in your Azure subscription. So along with a machine learning workspace, you get a key vault to secure your credentials, storage account to save your information, and application insights to monitor your machine learning workspace automatically created. So you get these resources created in your Azure subscription in this resource group that you choose. And once you are done with these two prerequisites, you're all set to get started with your first machine learning project. So if you are new to machine learning and you need a step-by-step guide, Microsoft has done an excellent job here as well. They have step-by-step guide on getting started with machine learning and their machine learning suite. So for the beginners, I would recommend getting started with a designer model of machine learning studio, which is an code-free mode of developing your machine learning application. First, to get a feel of how do you create your first project in machine learning and how things work, I would recommend you to get started with a designer mode, wherein you can create your new project, or you can make use of any of the existing projects to get a feel of how things work. So let me show you a demo of one of the existing projects that I have. These are the runs that I have executed to save our time at the time of demo. So here is my one of my machine learning project. Let us try to explore this and understand how we built this workflow. So the purpose of this machine learning project is to predict the price of automobiles. That is, I want to understand how the cars prices would be in the upcoming days or weeks, so that I can decide, or I can do an buying decision. So for which the first core part is my data. So here I have a predefined set of sample data sets which I can pick from. So here are some of the sample data sets that are supplied by Azure Machine Learning Studio for you to instantly experience this development environment. So I pick the automobile price data. So this is going to be my data. So this data is prepared for me to consume and then start with my machine implementation. So first, what am I doing to prepare my data? So I'm excluding normalized losses which has missing values. So I find that this particular data has got some this is a raw data. So in this raw data, I find some columns have got empty records. So as a sanity check, I'm going to select those columns in the data set and exclude those normalized losses which has many missing values. I'm not going to consider those values for my further processing or further analysis. Next step is cleaning the missing data. So I'm going to remove those values or rows which has got missing values. So next is I need to split the data. So what is the splitting the data? Splitting the data is, say, I have some 1,000 records of data that I need to use for training the system and also to test it, right? So what I do is I divide the complete data into 70% and 30%. The 70% of data, the total data that I have got, I would use for training the system. That is, I would say that this is how the type of information that we are going to deal with is going to be. So every record will have certain properties like make of the car, what is the kilometers it has done, what is its fuel efficiency, what is its insurance. Such critical information about every car would be present in the record. So this is the information that I am feeding to the system to train. So I'm going to make use of a linear regression algorithm and a very basic machine learning algorithm, which is, as the name says, it's a linear regression. I'm going to pass on this data again and again to the system so that it understand what is the form of data it is dealing with, and if the make is this, what is it going to be the price? If how this particular make of car has, what is the trend in the price raise or price reduction of this particular make of car? What is the what is the trend in it is trying to assimilate this information and trying to understand how each and every parameter that I have defined is going to impact the price of the car, which is the expected output of mine. So this linear regression algorithm, which is, I haven't defined this from the core, it is available. I am making use of the existing library, existing linear regression algorithm component to use the 0.7 percentage, that is 7 percentage of 70 percentage of my total data to train this module. So this is my core module, which is taking care of deciding a score assigned to every model that is being evaluated here. So this is my score module where every automobile record that I have fed into is being associated with a score. So it's in this green icon here says that I have executed this pipeline definition already. So this is my run overview. The status of this run is completed and at a time earlier this today. So I'm going to show you what is the score model's output at the time of executing this particular record. So let us preview the data in the score dataset. So this is the evaluation our machine learning algorithm has performed. So Toyota is the make of the car, and it is associated with an score label. I click on a specific record, I get to understand that so Toyota is leading within frequency of 11. Yeah, so the more the number of data, this is what I could understand. So imagine the feasibility of a human assimilating this information and giving me a statistic like this. So that is where, so this is a basic example of where machine learning is being employed. We also have scenarios where machine learning is being used in our day-to-day life, like movie recommendation. So see, this is another implementation which tries to recommend movie based on two data sets. So in the earlier case, I had one data set based on which I trained my machine to give me a prediction of how the price of automobiles are going to be in the future. But here I'm going to make use of two data sets, that is movie ratings, it's an and another IMDb rating. So every movie is going to be present in both movie ratings as well as in IMDb ratings. So based on these two parameters, the system is going to recommend me with a specific set of movies that I would prefer. Yeah. So what I'm going to do is I'm going to join these two data sets on movie ID. So movie ID is a parameter that is common against both of them, and I'm going to join these data sets using movie ID. And I have a Python script which does the selection of columns in a particular order that the recommended module requires. So my underlying module, so this script will take care of like processing my data to the format that is expected by my subsequent modules. And I do some data preparation here wherein I remove the duplicate rows and split the data for testing and training, just as we did in the previous stage. And here I am going to come into the training module wherein I have a module, train SVD recommender, which is taking care of considering the input data and recommending the movies based on that. And the score SVD recommender will have the recommendation available for me. So this is how my score rating looks like. So every movie and what is its rating associated to it. So when we change the data, this recommendation would definitely change. So this data would be specific to based on the imagine I in my Netflix ID, this is going to be different from what I based on what I am viewing or what is the current trends, what are the new releases. So this data keeps changing and the machine keeps training itself to come up with and score associated to every record, and that is how movie recommendation works. So this is the core. You get the correct data set, prepare it, feed into the system, choose the right algorithm to train the machine, and you get the output out of it. And this has to be an iteratively happening. You might have to reinforce the machine to learn from the mistakes, and then make itself more efficient to meet the demands. So and this is how my typical ML workspace would look like. I just showed you. So you have a compute instance associated with that. So here in this case, I have chosen and yeah, that can be like modified at the workspace level. So you can modify the compute instance. So this is a compute instance of mine, which is a standard F4S. This you can choose based on your business requirement, and you have integration to various applications that could enable you. See, we just used an design environment wherein there was not much requirement for me to code, but in certain cases, the business problem that I am solving might be too specific, wherein I need to write my own code, or I might existingly having a code which defines my business need, so I will have to use that. So in that case, you have integration with the best IDEs that we can ever work with, and that shouldn't be a showstopper here. And in the support to libraries is also extensive for us to make advantage of. So this compute instance would be a part of it. You have notebooks wherein you can handle your code, pipelines to define your design view data, and you can experiment. So the record that I showed you was an experiment. So you can have multiple experiments against each of your pipeline definition, and each experiment's outcome can be accessed right from here. You can access the compute models and data sets right from here. And for monitoring this, so when you get into the Azure portal, then you have access to all your resources here, and the default monitoring based on the metrics and application insights come right here. You can monitor the trends of your say, let me have an eye on the quota, like how many active cores are being utilized for each run whenever I have executed a run. So as we saw there at 8:22, I executed a run. So that is where my consumption has gone up. So this evaluation, the metrics monitoring on your resources are available here. We can also take advantage of tools like Serverless 360 to monitor these resources as an application. So now, having given you a basics of machine learning and how to get started, so the where you can get started is from Azure's machine learning documentation itself. So they have a pretty good documentation with very good get starting guide. So you can get your free subscription if you do not have an Azure subscription yet. Get started with an Azure machine learning workspace for free, and when you start executing for compute, you would be charged based on your computational consumption. So that is where you can get started with, and you can find very good examples, samples readily available in Microsoft Docs itself. And here, this brings us to the end of the session, and thanks for listening to me. If you have any questions, please raise them in the YouTube channel. I'd be happy to respond.
Yeah. Thanks, Alil. Like till now, there are no questions. If you have any questions, guys, you can reach out to our Twitter handle or LinkedIn. So thanks, Alil. Thanks for the demo and the session. Thank you.
Thanks, Suhas.
Yeah. Okay. So the next session will be by Murali. Like he'll be talking about how to build a Canvas application with Azure Cognitive Services. So over to you, Murali.
Yeah, thank you, Sugars. Let me share my screen.
Sure.
So, hope you're able to see the screen and you're able to hear me as well.
Yes, Murali. You can
Yeah,
click that hide button
yeah,
on screen.
sure. Thank you. Yes, so good morning, everyone. So that was a wonderful session from Elilersi as well as the Siva Ramakrishnan as well. Okay, so today we are going to talk about how to build a Canvas application with the use of Azure Cognitive Services. So first, let's get to into C. So what is cognitive services and what are the different pillars of the cognitive services? And directly we are jumping into the demo. So cognitive services is nothing but a REST API on the SDK that is provided by the Azure Cognitive Services in the space of machine learning services, which you can consume the Azure Cognitive services with the help of machine learning. Okay, so it has four different parts in the Azure Cognitive Services. One is the speech API, language API, and visions API, and decision API. So if you look at the speech API, so it provides basically all the speech transformation like speech to text, text to speech, those kind of things, and the speech translation. So when we use the Google translations, it's very similar to that. So you can use the speech translations and the speaker recognition. So speaker recognition is nothing but when we are in a group of meeting, when someone speaks, then it automatically gives the caption and who is talking what kind of text. So it will gives the speaker name as well as the what content they are speaking. And the language API is used to identify what is the nature of the content, is in which language it is written, what is it is sentiment analysis, it's a natural or sorry, it's a neutral, or it's a positive or negative sentiment. Those are the things provided by the languages API. And the next one is the vision API. So vision APIs helps you to identify images as well as the objects. So when you upload an image, it's identify whether the uploaded image is in a cat or in a dog or what kind of image it is. And even you can do the video analytics by using the visions API as well. All the facial recognitions will be used the visions API. And decision API, so it is used to identify any anomaly transactions in a given content. So that's the main use of the decision API. And so I don't want to give more explanations on the decision API and other APIs because it's already covered by the Shivaramakrishnan. So we'll directly get into the demo. So this is the product that we are going to build on the live session. So for this, we need to have an Azure Cognitive Services account. Then we are going to develop in a small Canvas application by using the Power Platform. And the Power Platform consumes the Azure Cognitive Services, and we will be passing the input text, and we will be identifying whether what kind of language the text was given, and what it is sentiment, whether it is in a positive or negative or it's a neutral, and what is the accuracy, how much percentage of this machine learning given the accuracy, and the linked entities and the key phrases and the named entities. So these are the something related informations about the particular content. So all this we are going to see it. So the example what you are seeing here is the positive sentiment, and you can see this is the negative sentiment, and the third one is for the language neutral sentiment. Okay, so let's go into the demo. So first, so I'm starting into the Azure portal. So I'm going to create resources for the Azure Cognitive Services, and I will be creating the language services, and I will create some of the connection points. So I'll go to the Cognitive Services. Then we need to go to the language services. Here I'm going to create the new language services. Okay, so the language services can do the sentiment analysis, key phrase detection, so what and all it can do. So that's what it is listed out here. So I'm going to create a new resource. So I'm going to use new resource group. So it's for AI Bootcamp demo. So I'm going to select what kind of instance. So I'll use the, so I'm going to use the paid one. So then I'm going to confirm. So I'm not, after this, I'm not going to change anything. So I'm going to leave whatever the system provides. Then it is getting validated and it will be created. Okay, so I'm going to create it. So by the time it is getting created, so we will switch to the Azure Power, so the Power Platforms. I'll go and create a new flow. So we have an issue. So when the Power Apps is not able to talk to Azure Cognitive Services due to some technical issues. So what we are going to do is from the Power Apps, we are going to call the Power Automate. Then the Power Automate in turn, it calls the Azure Cognitive Services. So that's the one thing that we are going to do it. So I'm going to create an instant cloud flow. So I'll just use the manual trigger. So at the start point, I'm going to run this flow in a manually. So let's see whether it gets creating it. So we wanted to fetch some of the keys. So I'm just waiting this to be completed. Yeah, so it's completed. So go to the resource group. So we got this. So keys and endpoints. So these keys and endpoints we needed to create a connection between the Azure Cognitive Services and the Power Automate environment. So this is in a manual trigger. So I'm going to add the sentiment detections. So we'll go to use this sentiment. So this API or this action will give returns me what kind of the sentiment based on the given text. So I have to give the unique ID. So I'm going to call the function called GUID. So it's in a always unique reference. I'm going to give some of the examples for this one. So what I'm going to do is by default, I'll go and pick some information here. I'll just give here just for the demo purpose. Then it needs the connection, so I need to create the connection. So definitely it will be asking me some details. So I'm going to save this. Just use create demo, save. So I'll go and create a new connection. So I'll fetch the account information from here. So I'll use this is the key. So I copied the key. I'm putting the account key here, and the API, the endpoint URL is nothing but this endpoint. So I'm just pressing this here. So now I'm establishing the connection between my Power Automate actions to the Azure Cognitive Services. So now let's save. And let's run this as a manual. So as we have given the input text by default as a hard-coded text, so it will run and it will gives us the result. And we can see it says the language sentiment is in a neutral, and it's giving the confidence score as the for the neutral is 0.67 and the negative and positive is very less. So here the highest one is the language neutral, or the sentiment is neutral. So that's what it is giving 0.67. So now let's see how we can bring this into the Power Apps environment. Okay, so let me return the results to Power Apps. So we'll click here, response to Power App Outflow. So I'm going to return as a text. So I'm selecting the, just giving the keyword. So here I'm going to give the text as sentiment. So I'm getting the output from the previous action. So I'm getting the sentiment as the result. Okay. Okay, it says it's a collection. Just a minute, let's go and see what are the properties that we have seen. So we need to fetch as a sentiment. Okay, it's returning as a collections. Okay, so we can use a variable to get the data. So we'll use the initialize variable. So we'll create a result sentiment. So we'll store the sentiment of the variable. So this is no longer required. We can delete this. Then I can store set variable. So I'm choosing the result sentiment. Then I'll be choosing this sentiment. Okay, so it will be automatically it's created the values. Now I can use this variable into the output. So I'll be adding another actions called Power Apps. Then response back to the Power App outflow. I'm returning this data into the Power Apps environment. So I'll be using the variable values. Okay, so now what I'm going to do is I'll change this trigger to different one. I'll be changing this trigger to different one. I'll be keeping the Power Apps as the triggering environment. So I'll be choosing the Power Apps. So now this flow can be called from the Power Apps applications. So I'm saving it here. So instead of manual trigger, I'm telling this flow should be called from the Power Apps. Now let's go to the Power Apps. So I'll create a new screen. I'll take a blank screen. Okay, I'll go to the actions column. I'm going to insert the Power Automate. So I'm just clicking the Power Automate. So it identifies what are the Power Apps that can be integrated within the Power Apps and the Power Automate. So now here I'm clicking the TA demo. So that's the flow that we have created here. You can see the name here. So I'm choosing the TA demo. So now it creates the connection between the Power Automate and the Power Apps applications. Okay, so now let's close this. Now what we'll do is we will add a button so into the screen. So we will go to the controls. So we'll add a button. So on button click event, we will call the Power Automate. So I'm just going to call TA demo dot run. Okay. So generally it gives the values after when you put the dot, so it will gives all the results that you have. So I'm going to just display in the notify just for the demo purpose. I'm not passing any arguments, so that I'm just giving the empty. So now let's run this Power Automate screen. So I'm saving it here. So now what happens is the Power Apps runs the application, and in turn it calls to the Power Automate. Power Automate, then it calls the Azure Cognitive Services and it gets the results. Now we can run it here. I can click this button. So it's executing it and it says the language neutral as the result. Okay, so now let's make it more interactive. So I'm just closing, I'm going to the design screen. Okay, so I will add a text box. So I'm adding a text input so that I can put any kind of text that can be passed to the Power Automate. So I'll put as the multi-line. Okay, so then I'm keeping the button here. Now let's go to the Power Automate. Let's make some changes. So instead of hard coded these values, I'm removing this and I'm telling the Power Automate get this input from the Power Apps application. So we have an option ask in Power Apps. So I'm skipping this. So then automatically this field should be passed from the Power Apps application. So I'm saving it here and I'm coming to the Power Apps. I'm just need to re-reference the TA demo connection. So I'm just removing it. I'm ensure that Power Automate it is getting saved. Yes, it is saved. So now I'll go to the Power Apps. I will add a connections, go to actions, insert Power Automate. I'm inserting again the TA demo. Okay, so now it gets added. So now you can see it is asking an input parameter. So what I'll do is I'll go to this button event. I'll just remove this. I'll put this. Then here I'm going to reference the text input. See what's the text input to. So input dot text. Okay. Now let's save this application. Now what we are doing is here is now on this button click event. So we are passing the input text box values to the Power automate, then it calls the cognitive services and it gets the results back. So let's run now. So now I'll copy this. I can put little bigger text. I'll come to the Power Apps. I put this. Let's see the output. So now it says the sentiment is positive. So I have some more examples for this demo. So I'll just put as the Tamil language text as this one. Yeah, it gives us the positive one. And so Buenos Dias. So this gives us a positive sentiment. I'll put I feel very sad. Again, this gives us a negative one. So it analyzes the sentiment. Okay, let's go and let's add some more actions into the Power Automate and we'll bring the results over here. So now I'll go here. So now let's add, what is this? So we'll add the detected language. So we'll identify what kind of the input text in which language it was given. So I'll go and click actions. So I will add it here. So I'll go to the text analysis. So we have an option called detect language. So this action will detect the language of the given input. So I'm just giving the unique reference. Okay, so here also I'm just telling get the input from the Power App. So we need to use the same input. So we have an options. So I'm referencing the same thing. Yes. Okay, so now let's see. So let's test it over here and see what are the output it comes, what is the structure of the output, so that we can grab the particular values into the Power App side. So I'm just click here, I'm just running it manually. So I think it's created a new connections. Let's test this. Okay, so I'll give this same input. Sorry, I'll give the same input here and let's see what is the output that we are getting. It says successfully running. So now we'll see what are the outputs that we are getting it. So it's identified the language as English. Okay, so its confidence score is 0.96. Now let's build the result variable, so that I'll go and add another variable. So initialize variable, let's initialize as result language, and it's a string variable. Okay, now let's come here and let's add a set variable. Let's choose result language. Then we have to use the detect language as the language name. Okay, so now and we will return the language results to the Power App side. So I'm just going to return a string result lang. Okay, here the values, the variable values of the result language. Okay, I'm saved here. Okay, so it's getting saved. So now I'll come here, let's re-execute it here itself. So I'm just giving, so I'm giving the input. So it says the flow ran successfully. Let's go here. So it says the language is English. Okay, let's bring this value into the Power App side. Okay, so let me add into another, I'll add a label. Okay, so that we can put these values here. I'll have 2 labels, 3 labels, 4 labels. Okay, so this is the sentiment, and we'll put this one. So we'll bind this value, value, and we'll bring this language. Okay, so we'll bring the value for the language here. So I'll just put empty lang value. Okay, so now we'll go to the button. So let's bring this into a variable. So I'm going to use set result, and instead of this one, so here what I'm doing is whatever the Power Automate returns, I'm storing it in a variable called result. Okay, then we will be binding the value into the labels. Okay, so I'll go to the text property. Now here I can get the value from result dot, so detected language. Okay, I think I have one more variable called result, so I'll just put result 1 2. Now I can come here, I can put result 12. Okay, let's execute once so that it will be binded. The reference variable which gets updated. Let's run this. Let's re-reference the connections as we made changes into the Power Automate side. So I'll go and delete it. I'll insert the Power Automate again. So I'm re-referencing the TA demo. Okay, so it gets added. So I'll give the text input to text. Okay, I will be storing into a variable called set result new. I'll be storing it here. Okay, so now let's come to the variable here. So I'm going to update the result property. So I'm going to result new dot result sentiment. Okay, so now the next variable, I'm going to read it from result new dot result language. So now I'll run the Power Apps application again. So I'll run this. So you can see the progress bar is executing, and it says it is a negative and its language is English. Let me put into good morning in Kannada language. So I'll put this. I'll ask to detect it. So it says it's a language neutral. So the sentiment neutral, and in the language it says Kannada. And sorry, let me go and put the text from the Spanish. Okay, so I'll put this. So now this is the feature of language API. So now we identified what kind of sentiment and from which language the data has been given. Okay, so next one, so we are going to add some more features. Okay, so I added this kind of an images based on the to just represent whether it's in a language neutral, sorry, the sentiment neutral, or the sentimental positive or negative. And I have bring on the accuracy score also, and it was displayed over here. So we have the linked entity. So linked entities identify when you given a particular context, so it identifies what are the entities it has been given. For example, so I added some of the values here in the demo. You can see it's a Friday. The Friday is identified from the data source from the Wikipedia. Then it identifies it's an entity, and it has a linking between the Wikipedia, and it fetches some information and it displays. So everything it does automatically. So even for the named entities also, so it identifies based on the person name or the object name or what kind of date and time objects, everything it identifies, and it gives what kind of category it is. So Friday is in a date and kind of a date and time category, and the subcategory is it says it's in a date range. Okay, so let's bring all these informations. So let's do some more things. Okay, so now let's go to the Power Automate. So we will add linked entities. So I'm going to add another actions. So I'll go to the text analytics. So we are going to identify the entity linking. So we have to use the version 3 for the entity linking. Okay, so here also the same thing. So I'm going to call a GUID. Okay, so the input text that should be paused from the Power App. So I'm going to reference the same thing here. Okay, let's save this, and as usual we test it from here. So we'll test it on the Power App for automate. So I'm going to run it manually. So I'm just giving run demo. So it says the flow ran successfully. Let's go and see the entity linking results. So it is saying, so when I give the name of Murli, so it says there is an actor called in Malayalam film industry. So Murli is the actor, and it identifies some of the information, and he has the Wikipedia here. So it is identified the Wikipedia as the data source as well. Okay, so now let's go and add some more thing as well. So I'll go to edit. We have something called key phrases. So it identifies the key information from the given context. So let me add the text analytics, and let's come here. Then it's called key phrases. The same, we have to give the unique number. So GUID, and the document input from the Power Apps. So we'll reference the same thing. Okay, let's save this and let's run this. So let's see the results of the key phrases as well. So we can see all the keywords of for the given text it is identified. So I have used the content management technology. So it's identifying that is a key phrases, new technology trends, software architect specialist. So all this information that brought from the given context. Okay, so let's add the next one as the named entities. So we'll come here. So we will add another action. So text analytics. So we have to use the named entity recognitions. So we'll use GUID here. Let's come here. Then we'll get the input from the Power App. So we'll reference the same thing here as well. So let's save this and run this. Okay, so all it's successful. So we can see the output here. So it is identify the entity as Murli. The category of Muralidharan Dinadayalan is a person. Okay, and there is another category, another entity identification is called software architect specialist. Again, it is a person type. So we can see different categories. See, we have I added as a at present in the text, so it gives it's in a date and time category. So it identifies different category, and we can have, yeah, you can see the alfresco, it's a kind of an organization. So that's what it is identified as well. So now let's see the complete demo of this application. So already I added all the screens, but the way of building is it's very similar. So we have to insert the Power Automate, then you put the results, and we can get it here. So now let's go and see the demo application that I developed yesterday. Okay, so I'm just going and deleting it. I'm just adding the same text. So I'm identifying the language, entity linking, all these informations as the input parameter, so that it identifies and it fills all the information. So I'm giving the analyze. So it is identify a lot of information. So the detected language is English, and it's a positive sentiment, and the accuracy score is 95. And the linked entities, so it is identified here as the Murli, and it identifies there is an actor in Malayalam industry is Murli, and the digital transformations, everything it identifies, and it is identifying the related linkings, okay, from the Wikipedia as the data source, and it returns all the hyperlinks. And these are the key phrases that it is there in the given text. So it is identified everything and it displaying it. And the named entities also, it's detecting what are the named entities and what is category and subcategory as well. So as I said, a decade, it's a date and time, and it's a kind of a duration. So we can see anything else, different things. See, mentor, it's a kind of a skill that is there. Murli is the person object, so that is also identified. Yeah, conferences, it's an event. So everything, the different categories, it is identifying and displaying it. Okay, so let's go back and put some of the negative sentiments. So as in the okay, so Murli is very tired, sad, and lazy today. See what are the things it's identifying it. Okay, it says it's a completely a negative statement, so that's what it's giving the negative sentiment. And it's again, it's identifying as the Murli as the name, and it's given everything. And the key phrases only it's identifying as Murli, and here Murli is a person object, today is the date and time, and it's a date range. Okay, so we'll put, so we'll put something like this. We'll add some informations here. Sorry. So we'll add some information about Sachin Tendulkar. Let's see how it runs. Okay, so we got good things. So we got the positive, and it's everything is in English. So we got all the related informations for the linked entities, and even the categories and subcategories as well. We got it, and even the key phrases as well. We have got it. Okay, so even when we got something, the numbers, the lot, the annotation, so it is giving us a quantity. So that's the way it is identifying it. Okay, and let's see different demos. I think we have tested this as well, so let's click here. Yeah, so it's identified as Spanish, it's a positive. Let's find some more examples. Yesterday when we tested, we got something nice results for this person. So I'm copying the Manjunath Siddhaba's about informations and putting into the text analytics window. Let's see what information that we are getting it. Okay, so based on his skill sets, we got some more linked entities. So for example, he has the kind of linking between the engineering. So we got the engineering, what is engineering and everything. He has the project management skills, so we got that project information skills, and business processing re-engineering. So we got all this information from the text to be analyzed values. Okay, so to be honest, we haven't used any of the, or we didn't know how the Azure Cognitive Services works. So what we did is we have created a resource in the Azure Cognitive Services, then we have directly consumed into the Canvas application. Okay, so okay, so if you are getting a problem while adding in a connection into the Canvas application, so you can develop into the your all the logics into the Power Automate. Then you can just bring the results into the Power Apps. How we did it, then you can display it. For example, you may get an error, something like this. So I'll go ahead and add a connection called text analytics. So you may get an error like this. So there is an error called WADLURA. So there is this issue around into the Microsoft Power Automate Power Apps forum for a while, but say everyone suggesting submitting to a ticket to the Microsoft support. Instead of that, as a workaround, you can put all your logics into the Power Automate, and you can just bring the results into the Power Apps. How we did it. So that is the workaround that I found, and I demonstrated as well. Okay, and I will be sharing this application as an exportable, as well as the complete flow that I have developed for this demo. so that anyone they wanted to try it out, so they can just export and import into their environment and just change the API connections and the endpoint URL, and you should be able to use it completely. So this is the final results that I worked on it, and we got all the results for this nice UI. Okay, and if there is any questions, please post into the YouTube channel, then definitely I will be happy to assist. And as I mentioned, then I will be sharing these Power App applications as well as the Power Automate flows as well. Thanks for joining, and thanks for the opportunity, Kupraso and Sugos as well.
Yeah, thanks, Murali. I think that was very wonderful demo. Thanks for the detailed explanation. So, guys, if you have any doubts, you can reach out to him, or you can also post your questions in the comment section. We'll pick it up. So, thanks, Murali.
Thank you.
Yeah, okay, so the last session, unfortunately, Pandyan was unable to join, but we have one more session from Kuparasu. He'll be talking about like how to analyze faces with Azure Functions and cognitive services. So over to you, Kuparasu.
Can you able to see my screen, Suras?
Yes, Kuparasu.
Yeah. Good morning, everyone. I am Kupras Nagaraj, Senior Software Engineer working in Covet.co and Microsoft MEP since 2016. So today I'm going to talk about analysis phases with Azure Functions and Cognitive Services. So already you know the Cognitive Service free-defined cognitive AI services. So today I'm going to how to integrate Azure Function with cognitive services with one demo. So 1 minute. Yeah, this is my session agenda. So quickly I will explain what is serverless and Azure Functions overview, Azure Functions features, and Face API, and finally we'll give the demo. Okay, so first, what is serverless? Why I am talk about serverless means the Azure Functions and the cognitive services are uh, serverless technology in Azure. So we need to know what is serverless. Serverless means we can deploy our application without worrying about the infrastructure. For example, I'm going to build one website. So I'm going to deploy the website in the Azure portal, but I no need to manage any servers. Okay, just I'm going to write one small application and host it in the Azure serverless service. So I don't bother about that infrastructures. That is a serverless. So very simple. We are not doing anything in the infrastructure side. Just we are going to manage our application. That is serverless. The Azure provide a number of serverless services. For example, functions and storage account, cognitive service. So they are providing number of services. These are the few example for Azure serverless. Okay, so Azure Function and cognitive service both are the serverless technology. Okay, and so it automatically scaling up whenever the request come, that automatically the infrastructure scaling is automatically scale out and scale in is happening. And also we have the consumption based pricing model. We are going to pay only how much resources we used in the particular days. Okay, we are not paying for the entire month, just we are going to pay only for our usage cost. Okay, that is a consumption based pricing model in the serverless. So what is the Azure Function? Azure Function is very simple. We are going to run a small pieces of code in the Azure portal without worrying the application infrastructure. Okay, so if you are very well in the web app in the Azure service, so we need to configure the app service plan. But in the Azure function, we no need to do anything. Just we are going to write one small application, small app, and we are going to run in the cloud. And we are not managing any infrastructures. Okay, the Azure functions providing different type of triggers also. So that triggers means when the applications is started. So we have the timer trigger, queue trigger, and HTTP trigger. So timer trigger means it will run every 5 minutes we can set it. Every 5 minutes this function will execute, or every 1 hour, or every day, or every weekly once we can set it. The http trigger means just we are going to hit the http in once we write Azure function and deploy in the portal, Azure portal, we will get the one http endpoint. Whenever we hit that http endpoint, that is a url, the function will automatically executed. It provide different languages also, so Python, Java, C Sharp, JavaScript, and PowerShell and FSR. Also, we can connect with blob storage, Cosmos DB, and SendGrid. Other the Azure function will connect with the another Azure services. Okay, so that is we are going to call it as binding. So we can integrate with the blob storage, Cosmos DB, and SendGrid also. So this is these are the features serverless applications. The function allowed to develop a serverless application on Azure. We can previously explained we can have the choice of languages, and we are going to pay only pay per use model. And if we have any dependencies like any libraries, we can use our existing library in our Azure functions also, and we can easily integrate it with the other services also. The flexible deployment, the setup continuous integration and deployment our code through the GitHub. If for example, if our Azure functions code in GitHub or Azure DevOps services, we can easily connect with the Azure service. Okay, and what is the phase services? The phase services provide a algorithm that detect and recognize and analyze the human faces, human face in the image. For example, if I am going to compare two images, both are same person or different persons. Quickly, I can show one demo in the Microsoft documentation site. You can see this is a Microsoft documentation site for face API. You can have a face API all the informations here. Here they have they given two demos in this website. So one is face verification. For example, you can see here the both persons are same. You will get that confidence value 0.93. So for the value start from 0 to 1. Okay, we will get, if we compare two images, we will get the uh, confident value from the 0 to 1. Okay, so if 0 means it's two persons are different, 0 to 5 means that two person may be that different. If we get 0.5 on and above, maybe the person is same. Okay, so here I'm going to add my photo. Okay, I'm going to browse. I have on desktop. Here I'm going to add this image to here. I will use submit. But yeah, you can see here 0.09, because the both images are different. The confident value we will get only the 0.09. That means the both images are different. Okay, here I'm going to add my image, another image. Maybe I can add this image. You can see we will get 0.93, because it means the both images are same person. So this URL available in the Microsoft this demo available in the Microsoft documentation site. I will share this in the command section. You can also verify your images are two different images. You can verify these easily. You can verify the images in this site. Okay, this is one very quick demo in the face API demo in the Azure documentation site. So now I'm going to talk about that Azure function. Okay, then only we can connect with the Azure function with Cognitive service. So I can quickly go to the Visual Studio. So already I have installed Visual Studio 2019 in my machine. So I'm going to, if you are familiar with the Visual Studio, then you can quickly understand this. So I'm going to create a new project. So new project means I'm going to create a new Azure function. So here I'm going to choose the Azure function, or otherwise you can find here. Yeah, I'm going to find, I find it, and I click next. Here I'm going to face API, sorry, this is Azure function demo. So I'm going to funcs demo. Okay. And you can see here, previously I explained, we have that number of triggers in the Azure functions. So you can see the blob trigger and Cosmos tree trigger and durable functions, event grid, event hub trigger, and HTTP trigger. So we can use the different purpose of this trigger. For example, whenever I upload any files in my blob storage, uh, this trigger will execute. Okay, so here I'm going to choose the HTTP trigger for the simple demo. So I click next. You can see the hello world kind of application is came, and just I'm not doing anything, just I'm going to run this Azure function. So how the Azure function will run, you understand how the Azure function will execute. So once I run this sample code, I will get that localhost URL. So this is a HTTP function. So the function will provide one endpoint. Endpoint means one URL. When we call the URL, the function will execute. Okay. So I put the breakpoint here, and I copy this endpoint. I copy this endpoint, and I can go to the browser. Just I'm going to call this function. You can see here, when I hit that URL, the function will started. The execution is started. Okay, I click continue. You can see here the HTTP trigger function execute successfully, but we need to pass the name parameter. Okay, so once we pass the name parameter here, so I'm going to send name parameter is kupu. You can see here, and I can execute next step. You can see here we get that kupu in the query string. Okay, so just I'm click continue. Then you can see here hello kupu. This HTTP function is executed successfully. This is a simple way to create Azure function in Visual Studio. Okay, and now I'm going to explain. Yeah, this is a simple demo analyzing the faces in the Azure faces using the cognitive service with Azure function. So I already created this demo app. So what I am done here, just I need cognitive services face API subscription and URL, subscription key and URL. So if you want to create new key, then you can go to the Azure portal, portal.azure.com. Then you can log in with your Azure subscription. If you don't have a Azure subscription, you just create sign up this portal.azure.com, and you can create one trial account. Then you can use for this demo. So this is already I have the account. Then I can click create and go to the AI and machine learning section and click create the face API section. I can quickly click create. Then here I'm going to choose I have different subscription. Then here I'm going to choose resource group and region and name, and we can see here we can free tier face API also available. We no need to pay anything. So we can call this API 20 calls per minute and maximum 20,000 calls per month. So this is a free service. So if you want to call um, every seconds, or we need to call more than 30,000, so we are going to pay extra. We can choose another pricing tier, the standard tier. So we have the two tiers. So one is free, another one is a paid one. Okay, so for this demo we can create a free one. So once we can choose this and name face API. This is demo how to create face API account in portal. can click create and just, oh, sorry, the validation is failed. The face API, it's the subdomain, it's not available because it's already taken. So I added the another subdomain face API Kupu demo. This subdomain is available, so I can quickly create. So it take a couple of seconds to create in Azure portal. Once the deployment is completed, we will get the subscription key and one URL. So using that subscription key and URL, then only we can analyze the images in the Azure function. Yeah, it's quickly created. Then you can go to the key and endpoint section. Then you can see the key. We have the two keys and this is the key one. Then you just copy this key and you can use this endpoint URL. Okay, so previously I created that endpoint. Sorry, previously I have that API key and cognitive service face API URL, and here I have the images and the URL. So I need to pass what this application, we need to send one image URL, and once we pass the URL, then it will take the image and analysis the faces using that cognitive service face API. Then we will get the face. You can see the we will get that emotion value and the person age. Okay, the person the happy property, you can see we have the different properties and happy, age and gender. All the inputs get from the face API output. Okay, so once the face analysis is done, then we will get that happy attribute and age attribute and gender attributes. So based upon this function will execute it. Okay, so let me try quickly because we have the already we crossed the 12 p.m. So okay, the port 701 is unavailable because I think another Azure function is running. So just I'm going to close this. Oh no, job Azure functions is not. Okay, so I will face some issue, but you can understand. So just we need to pause the API key and cognitive service endpoint URL and images. So once the function get this input, then it would analyze the images and given the output for the age and happy and gender informations. Okay, so I will share the face API documentation in the chat window. Okay, then you can easily understand how the face API working in Azure. Okay, definitely it will help you to implement in your real-time applications. So any questions, I will answer it. So Sugas.
No questions, Gopras.
Yeah, thanks everyone for joining this event.
Yeah. Thanks, Kuprasu. Like, if you have any doubts, you can reach out to him. His social media handle is Kuprasu360. If you have any doubts, you can reach out to him, or you can also raise it in the YouTube comments. Okay. Um, Okay, so I think we came to the end of the event. So basically, we had four sessions. So first, we saw about Azure Cognitive Services, and then we saw something about machine learning and how you can train your models, and then we saw like how you can build an application in Power Automate, and finally we saw how we can analyze face using Azure Function. So basically, it's done without much effort. So that's the power of Microsoft technologies. Like, you can explore more about this. They have good documentation and good set of videos in YouTube. And so basically, about TechMe 360, so we have a meetup group called TechMe 360. You can go to this URL, meetup.com/TechMe 360, and there will be a join button here. You can join. You can join this meetup group. uh, so whenever we create event, you'll be notified. So whenever there are new events, you'll be notified. So basically, we focus on Microsoft technologies and Angular. So we do events every month, a third Saturday or second Saturday, and every month we'll have these tech events. So you can join this group, and if you have any feedback about this event, or anything you want to share, which will improve our community, you can just tweet us using this TechMe 360 handle. You can also DM us if you have any improvements or feedbacks, either positive or negative. Any feedbacks, it's fine. If it helps to improve our community, we are good to pick it up. So this is our Twitter handle, TechMe360. You can also follow this handle if you need updates about our event. And so we also have a YouTube channel called TechMe360. So basically, the last 2 years, so basically we were doing as an in-person event, but due to COVID, the last 2 years we went on virtual. So we have several videos covering various technologies in Microsoft technologies, like Azure for Developers API, messaging services, and some workshops in Angular, etc. So if you are interested, you can also go to this YouTube channel called TechMe360, and you can watch out videos. And if you are interested, you can also subscribe us to the YouTube channel. So yeah, so thanks everyone. So thanks for joining us, and thanks for the support, and stay safe, guys. We'll meet next month. So thank you.